So today we will see some terms related to circle. This is the definition of a circle. If there is a fixed point and if we are taking all the other points which are at a fixed distance. From here, this distance is r. Then all the points which are at a distance r, they will all make a circle. So this is the definition of a circle. So that fixed point is called the center of a circle, and that fixed distance is called radius of the circle. Similarly, we have three portions in a circle is divided into three parts. A circle divides the plane into three parts. Correct? Inside the circle, which is called interior, and the circle, and outside the. This is inside the circle. Then this line, which is showing the circle, and then outside the circle. So this interior, inside the circle, this portion is called interior of the. This whole portion. This whole portion is called interior. Then the line which is showing, which is drawing the circle, there's the points on which line, this line circle is called circle. So some of the portion will be used to drawing it. And then outermost portion, this outer portion is called exterior of the circle. Got it? Diameter, you know, radius and diameter. Diameter is the longest chord of a circle. Correct? This is a circle. If you want to know that what is diameter, that this is a n longest chord. This is a chord. This is also a chord. But whenever the chord which is passing through the center, this will be the longest chord. So we can say this longest chord is called its diameter. Longest chord of a circle is called its diameter. And you know that diameter is the double of the radius. This is the center O, and this is R, and AB is the diameter. So denoted by D, D is equal to 2R. Diameter is equal to double of the radius, and radius is equal to half of the diameter. Yes, got it?
Yes, sir.
Then we have arcs. Circle is divided into, when you will take 2 points, suppose I'll show you. If you are taking 2 points, P and Q, this P and Q. Okay, so it is dividing into 2 arcs. This one, this arc, and this arc. So whichever is big arc, that is called major arc, and this is small, so it is called minor arc. So major arc and minor arc. So that's why we used to write, if we are showing major arc, PQ. So P to Q, then Q to P we will write minor arc as, generally minor arc is QP. Or in any question, if major arc is given and points can be somewhere else also. Point can be anywhere. Then there is a condition which is when the point comes, suppose P will come here and Q will come on the diameter. These 2 points are on the diameter of the circle. Then how can you say major and minor arc? We cannot say major and minor, because if these are not the points, end points of the diameter, then one arc will be bigger, one will be smaller. So bigger will be major. But when P and Q are on the diameter, so it is dividing into two semicircle. So these are not called arc, then we say semicircle. PQ, semicircle, semicircle PQ. Both are called semicircle PQ. Okay, got it? These both the arcs are called a semicircle. Circumference, you know that the length of the complete circle called its circumference. Length of the complete circle means if you start moving from P point and you will go and take a round, come back to P. So this is the total length of the circle. The length of the boundary of the circle is called its circumference. So circumference of a circle is circumference of a circle is the length of the boundary of the circle. Length of the, or better to write total length of the boundary of the circle. Here we are we are doing geometrical, means geometrically we are studying. When we study mensuration, then we will consider the area of circle, circumference to pi r, but here we are doing it under the heading of geometry. So these are the terms and segment. After that, we have segment. So similarly, segment and sectors. You should know the difference between segment and sectors. Correct? So I'll show you about the segment and sectors. This diagram will clearly tell you about the sector and segment. Now see this. This is what PQ is, what here in this one. PQ is what? PQ is chord. If I will write PQ like this, then it is an arc. Correct? And here it is minor arc. It is a minor arc in this. So this is the arc and this is the chord. Understood? This distance from P to Q, this is called chord, and this distance is called an arc. The chord divides it into two parts. Again, the chord is not a diameter. It will divide into two portions. One is bigger. This one is bigger portion, and this one is a smaller portion. Or if this same thing will happen if PQ will come here, suppose PQ is here, then it will divide into two portions, but this will be the minor segment, this will be minor, and this whole portion will be major. Okay, so this divides into segment. This is called segment. So segment, we get the segment by dividing it into two parts by chord. The chord divides the circle into two parts. One is major segment, second is minor segment. But what will happen if PQ is a diameter? Then it is called region. In this case, this is called P, and Q, if it will become a semicircle, then both the segments are same. So in this case, we say semicircular region. Called above one and below one are called semicircular region. Semicircular regions. If PQ is a diameter. Got it? But when two radii, correct, one, two radii, these are the OP and the R, the region between two radii and R, this is called sector. This region is called what? Sector. So again, this sector, one is major, one is minor sector. The sector is the region bounded between the two radii and R. And segment is the region between chord and R. Got it? So this is the difference between segment and sector. Got it? Turn it out. And semicircular region, when it becomes a diameter, then both the regions are called semicircular region. Understood? You understood everything, you will tell the answers of these questions. Now we have fill in the blanks. Here you can see. Got it? Here the center of a circle lies in exterior or interior? Where?
Interior.
Interior, because inside it lies inside, so you can do it in your textbook with the pencil. Interior. A point whose distance from the center of circle greater than its radius lies in. Greater than the radius means outside. Greater a point. Suppose this is a circle and this is radius, and greater than radius means outside the point. The point will lie in the in exterior of a circle. So here exterior. The longest chord of a circle is a
Diameter.
diameter. An arc is a when its ends are the ends of a diameter. An arc is a when it becomes a diameter, then arcs are called
Semicircle.
semicircle. Segment of a circle is the region between an arc and segment. I told you this is that's when you draw
Chord.
chord and arc. A circle divides the plane in, on which it lies in. Circle divides the plane in how many parts? 3 parts. One is exterior, interior, and circle. So it divides into 3 parts. Got it?
Yes, sir.
Yes.
Then our exercise has one more question. There we have to write true and false. But these are very basic things. True or false? A line segment joining the center to any point on the circle is a radius of the circle. Joining the center to any point on the circle, is it a radius?
Yes, sir.
So it is
True.
true. Yes, on a circle, any point from the center to anywhere on the circle, it is always a radius. That's why it is correct. Then next, a circle has only finite number of equal chords. Equal
False.
chords.
False.
How many equal chords you can draw with the circle?
Infinite. We can draw
Finite.
everywhere.
This is false. You can draw finite number of equal chords because circle has infinite number of points. Circle is divided into three equal arcs. Each is a major arc. Circle is divided into three equal arcs. Three equal arcs. Circle is divided into three equal arcs. Equal arcs means we will take equal distance. Means this suppose here and 1, 2. A circle is divided into three equal. Three equal arcs means 1, 2, 3. Suppose so each arc is equal to each other. So how can you say major or minor? Each is a major arc. No, we cannot say major minor. All three arcs are equal. Okay, and that too, if you are dividing a circle into three equal arcs, so each arc is a minor arc as compared to other this full arc, but they compared all the three arcs. So it is false. Got it? A chord of circle which is twice as long as its radius. Chord which is twice the radius is a diameter. True or false?
True.
True, because double is the diameter. Sector is the region between the chord and its corresponding arcs. True or false?
False. The segment.
False. Yes. Because in this one, they said actually what they said. They said this is a circle, then they said chord and the corresponding arcs. Yeah, this is a chord. And arc, there are no corresponding arcs. Only one arc. So this is corresponding arc. This is segment, not a sector. Sector is what? When we have two radii, this is called sector. This is segment and this is sector. This is a sector, and this is segment. Okay, got it? A circle is a plane figure.
True.
Huh? True. It's a plane figure. So this is all about exercise number 1. 10.1. Finished. Then our next topic I'll explain. Angle subtended by the chord at a point. angle subtended by the chord at a point. So we'll take one circle, correct? Angle subtended by a chord at a point. So if you draw an R, and R is chord, not R chord. If you draw a chord, this is a chord. AB is a chord. The angle subtended by a chord at a point. So means it can subtend the angle at which point? Center. Angle subtended by the R or by the chord at point O. Center, it can subtend an angle at center. The angle subtended, this is what? This is the angle subtended by the chord. And similarly, it is also the angle subtended by the R. But this chord can subtend at any other point also. Here, 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 anywhere. You take this point, here also it will make some angle. Correct? You will take another point, here also it will make some angle on the circle. And here also it will make some angle. So any point it can make. So I have shown O point, P point, Q point, and R point. So this is making angle at center. It is also making the angle at other points. Okay, got it? So this is called the angle subtended by the chord at a point on the circle, and angle subtended by the chord at center also. So now we have theorem. Theorem 10.1. You can see this theorem now. The equal chords of a circle subtend equal angles at the center. Equal chords. So it is given that equal chords, and we have to show they are making equal angles at the center. So equal chords, we have to take equal chords. Let two equal chords. These are two. This is take one center. This is the center, suppose, and equal chord. This is a given equal chord, and another equal chord you can take anywhere, but these are two equal chords. These are two equal chords as it is given in the question, equal chords. So that AB and CD are two given equal chords. Subtend angles at the center. They are subtending angle at the center O. So this is making an angle at center O, and this is also making an angle at the center O. These two angles, this is center O, and this angle are equal. That we have to prove. Means if we give the numbers, number 1, number 2, we have to show proof. And what is given? This CD is equal to AB. It is given. So whenever you are proving the theorem, you should write the given conditions. So what are the given conditions? Two equal arcs, a circle. First of all, you will write always like this: a circle C of center O and R radius, any radius R, with two equal chords. Which are the equal chords? A, B, and CD are two equal chords. And we have to prove that they make same angle at the center. That means we have to prove angle COD is equal to angle AOB. That is, we have taken for our convenience angle 1 is equal to angle 2. This we have to prove. So proof, here we will use SSS. We will use consider these two triangles, prove that they are congruent, then it will be proved. Congruency is also there, SSS congruency. So you have seen already congruency. So in these two triangles, in triangle COD, if we consider triangle COD and triangle AOB. So already given that COD I have taken first, so CD, I'll write first the side of COD. CD is equal to AB. Why? Because it is given us that these two chords are equal. Then obviously OD will be equal to OB. OD will be equal to OB because the radii of the same circle. They are the radii of same circle. Similarly, OC will be equal to OA. The reason is same. Therefore, by S congruency, triangle COD is congruent to triangle A. When they are congruent by CPCT, angle are equal. Implies that angle COD, angle COD angle COD is equal to angle AOB. That we have to prove. So therefore, equal chords subtends equal chords of a circle subtends equal chords of a circle subtend equal angles equal angles at the center. Equal angles at the center. Finish this theorem. Okay. So that's all for today.